Hi everybody. In this video I want to review some key aspects of matrices that we'll be using in the coming days. So here we go. Matrix multiplication. So imagine I've got a matrix with these elements A, B, C, and D, and another matrix with these elements E, F, G, and H. We can multiply those two matrices out. We do that as follows. I take A times E plus B times G and put that here. AE plus BG. All of that is this first element. Then I can do the same thing over here. A times F plus B times H goes right here. AF plus BH. This element right here I get from C times E plus D times G. CE plus DG. And finally, this last element here I get from C times F plus D times H. CF plus DH. And that's matrix multiplication. You have to have an appropriate balance between rows and columns. So since I take this element times this element plus this element times this element, I could continue as long as I have the same number of elements in this row, in this column, as I have in this row. So that's the way that things need to multiply out. All right, I can multiply a matrix by a scalar. To do that, you just distribute the scalar in. So multiplying this scalar by this matrix, I would end up with a 4-element matrix. NA, NB, NC, and final element ND. Of course, if I had something like this, I could also factor the n out. So factoring out a scalar is just basically a backward process of multiplying by a scalar. Let's see, I should do matrix addition. So let's just sort of separate these two things here. If I want to add this matrix with this matrix, I have to have the same number of rows and columns, so they've got to have the same dimensions. This is a 2x2 matrix, this is a 2x2 matrix. So if I had a 2x2 and a 2x3, I couldn't add them. You got to have the same number of rows and columns in both matrices. So to do that, I just add them element by element. So this element would be A plus E. This element over here would be B plus F. This element right here would be C plus G. And this element here would be D plus H. And that is matrix addition. Basically, you just add them element by element. All right, finally, something I need to mention that you may have not seen in an earlier matrix course, the adjoint of a matrix. So to take the adjoint of a matrix, we write the matrix and then put this little dagger symbol. So sometimes we'll give this matrix dagger. Well, that's the adjoint of this matrix. To take the adjoint of the matrix, what you do is you flip things along the diagonal and then take the complex conjugates of all the elements. So along the diagonal, I still keep my A and my D, but if I want to take the adjoint of this matrix, well, I need to flip these elements across the diagonal. Now I'm not done. I also need to take the complex conjugate. Now, in the event that you have real numbers, the complex conjugation does nothing to them because real numbers are self-conjugate. But in general, you may have imaginary or complex numbers. Taking the adjoint involves flipping everything along the diagonal and also involves taking the complex conjugate of all the elements. All right, so those are some of the key operations that we'll be using with matrices, and that's all for now. Thanks.